Just discuss what you know about it. Okay. So, ladies and gentlemen, at first glance, it appears to have two asymptotes, doesn't it? Like it appears to have a vertical asymptote at x equals -5, and then a horizontal asymptote at y equals 2. But yeah, Shiv. Yeah, if you play with this algebraically a little bit, you can factor out that 2. You're left with x plus 5 here, x plus 5. Oh, I'm frozen. Thank you. These cancel out, leaving us with f of x equals 2. So what does this graph look like? Oh, it's a range. Will you please discuss with your neighbor what does this graph actually look like? So show me what it looks like. Okay, so it's like this. With 0 right there, you have a 2 right here. Like this. Almost. There's an issue. What's it?
Can't be 5.
Yeah, x can't be, well, x could be 5. It just can't be -5. Right, we have to keep the domain. If up here x can't be equal to -5, do we agree with that? Then over here also x can't be equal to -5. So the graph is going to have a feature we haven't discussed. It's going to have what's called a hole. Where have you seen these before?
On number lines.
On number lines, we're talking about just less than or greater than and not equal to, right? When I would ask you, or when your Algebra 1 teacher would ask you to graph this on a number line, do you remember how that started? Started on the number line with that hole there, the open circle. And then in this case, you would shade to the right. It's the same feature. This is a hole. Let me graph it again so you can actually see what it looks like. It's just nothing's there. Everywhere else, whatever you plug in, it would be equal to 2. Let's see, is that true? If you plug in a 10, you get 30 over 15. If you plug in -1,
Not -5.
you get 8 over 4. But if you plug in -5, you just can't. You get 0 over 0, which is not any particular value. That's why we need to have that hole there. So we are going to be discussing those today. How about end behavior of this function? Discuss with your neighbor what's the end behavior. Is there end behavior?
Oh, I know. Wait, it wouldn't change.
And behavior x is going to plus or minus infinity. I think it's the same here, so I'll put them together. For both of these, it's equal to 2, just the same as it would be for a horizontal asymptote. It's just those y values not only are they going to, they actually are to, but they have the same limit. Going to the same place. Yeah. Okay, let's we're actually gonna do some work in the packet today. Dun, dun, dun. So go to day 3 in the packet, please. Day 3. We're not going to be doing any of these tables, though. Day 3. I don't know what page it is, actually. Does it make sense that this function connects to this graph? Just take a moment to make sure you and your neighbor both are here and like, what do you see? How are these connected?
Well, the line.
1 is undefined. 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 1 is unde
Also,
How do I see
know,
this, like,
the vertical.
graph, whatever. How are they related? And you can see that the line is white.
I think goes to
Why? That one. Kind of look like that's where the dot function. So it'll be important.
that was the horizontal, yeah, and then the red line would be with 9 horizontal dots. You think it would be? Well,
I'll talk about invertible yet. Okay, so right now you're just talking about what are the connections between the graph, the function itself and the graph. So I just want to hear some of what you talked about. Lee, what'd you get? Any connection between these two?
Well, JC, like, the two asymptotes. That I could say,
Can you be specific? Like here, we know that the graph. Are we good with that? Nice. Okay, so yeah, that definitely matches here. Any other connections? Could you just discuss why the intercepts make sense? Maybe you forgot to talk about those, but let's just make sure that they make sense.
And then.
That's how.
Yes,
Yeah.
But there.
Yeah.
You plug in a zero. Wait, the y-intercept is -1 now.
Actually, flipping here, so that the zero, then that x equals zero.
Yeah. It's right there. It's right here.
Is it perfect? Is it perfect? Are you seeing it? Let's see. Simran, what do you see with the intercepts?
You plug in the horizontal asymptote, which is -1.
Like in
then-
the horizontal.
Or,
asymptote.
sorry, you set it equal to the horizontal asymptote.
Are we trying to see where it crosses the horizontal asymptote? I'm looking for intercepts, specifically the like x-intercept. How do you find an or y-intercept? Someone do you remember?
Plug in like, okay, y equals 0.
Yeah, for y equals 0, we'd find the x-intercept, and if we do that, then we get.
-1 now.
Do we? No? Yeah, how do we solve this for y equals 0? We just set the function equal to 0, and the only way that a fraction could be equal to 0 is if the numerator is equal to 0. So we get that 2x plus 1 equals 0. Right, Simran? And then from there, just sprinkle a bit of algebra, and you get x equals -1. Which you said a long time ago. I just wanted you to explain it because it could have come just from looking at this. And I didn't want that. I wanted to like go from the function to the graph. We just verify that x equals -1. Okay, so that's the x-intercept. Y-intercept? Why does that make sense? Shiv?
Set x equals 0, then you get 1.
Yeah, I said x equals 0, and then you can see that one's a little bit easier, is it? -1. Are we good with those? Okay. Any questions? Does this have an inverse? Show me how you know. Show me how you know. So, I didn't say tell me how you know. Show me how you know. Let's discuss with your neighbor. A lot of people are just like looking at their paper. How do you know it has an inverse?
Totally like.
Also, it has to have the horizontal.
Show me how you know.
It's 1 to 1, like every input.
We know because this, right? The horizontal line passes the horizontal line. Without doing any algebra, I'd like you to discuss with your neighbor what's the domain and range of the inverse without doing any algebra.
Domain of.
This kind of deletes the invert and so that would be still.
Of alphabets.
All we have to do is to.
Yeah.
Well, I was working.
That's.
Oh, yeah, domain.
Oh, to two. Yeah, and then two to.
Domain is, yeah.
Yeah, we have.
In the absence.
Because the. Oh, wait, no, I got it.
Wait.
Think about 10 seconds, I will be going. Yeah.
Yeah, because if you think about it, why, like, and there's like, it unions at one. I would assume.
Okay, so. Elle, can you help us out? How are you supposed to get the domain and range of the inverse? We haven't even found it. Oh, okay. What is the domain of the original function? Okay,
Negative.
I think this is what I heard. Is this right? Cool, so domain of the inverse is? Is this clear, everybody? Nice. Nicely done. Thank you for the interval notation. Instead of using interval notation, do you know another way to say this? For the original function, what the domain is? X not equal to 1. But you also want to qualify it, like, so what is it? It's everything else, all the other real numbers. And what's a symbol? Epsilon, yeah. X is an element of the real numbers. It's not like the integers. It's not the whole numbers. It's anything but 1. That's like a little e with a c looking. It's an epsilon. So you could say that, just remember, if you're doing that, when you go to the range here, it'd be y could not equal 1. So just be mindful about that, because if you put x's for the range, it's a little bit strange. Oh, that was actually a t-shirt. That's a nice rhyme. And of course, y would have to be an element of the real numbers. Any questions? Okay, well, maybe your question is, can we figure out the inverse algebraically, please? If so, the answer is yes, you may find out the inverse of this function algebraically. Take some time. I think there's actually some room to do this in C. Yeah, down in the next page. What's that?
No, we just like already know it, just we already.
Oh, let's see.
Oh, just like.
So you're using algebra to find the inverse.
Oh, you're right. Just like flip over.
So, you know, what's that? Why?
This is destination.
First, I would.
Then you basically. Your numbers are. I got it as well.
I would factor out the 2. Wait, no, I would factor out y minus.
Oh.
Like,
And then it's a-
y.
F inverse of that.
I think you just multiply.
15 seconds.
Okay, give me a second.
See, that's the smart, but also. Right.
Okay. Shiv, could you help me out here?
Okay. That's exactly that. So you have 2y plus 1 over y minus 1 is equal to x.
Okay, so you thought about this as y. I know, but x equals this. Now, how did you know that this was the first step? Are we good with that? Did we ever study inverse functions in this class?
Yes.
Okay, so nothing changes. Yeah, that's how to find inverse. Continue.
And then you multiply both sides by y minus 1.
Okay. So you get,
It's y minus equals 2y plus 1.
okay. But how are you supposed to solve for y now? There's two of them.
And you move y to the left and move x to the right.
Okay.
Xy minus 2y equals x plus 1.
Oh, nice standard form. I like it.
And you divide both, you factor out the y from the left,
That is key.
and you can divide x plus 1 divided by
X plus 1 over x minus 2. And instead of that y, we're going to write
the inverse of that.
f inverse of x. Or the inverse of f of x is perfect. Just don't say f to the negative first power of x, please. Don't say f negative 1 of x. That's all incorrect. F inverse of x, inverse of f of x. Any questions? Would you please take a moment to just see why this makes sense compared to what we started with? To discuss with your neighbor, why does this make sense?
You mentioned how like the side.
I think they don't realize it. Yeah, so we awesome.
Yeah.
And that would make sense because X.
Okay, so why does this make sense? Nathan, what do you see?
Like matches like the range and domain that we had, which we got using the. When we got the inverse, like it matches like the same.
Specifically,
The horizontal.
yeah, we can see here the horizontal asymptote. Is that one? The vertical asymptote, is it 2? Nice. Any other things that you see? What do you notice? Thank you, Nathan, by the way. Yes. Oh, before your question, I want an answer to my question. What else do you notice? Hold on to your question. I definitely want to answer it.
I don't know what word to do.
The way your face is drawn.
Yeah.
Equal, what's up?
What else do you see? What's that? That's just horizontal aspect. We talked about that. Why do
Vertical asymptote.
you guys keep ignoring the intercept? Why do you keep ignoring them? You see the x-intercept? It's negative. X-intercept is -1 and the y-intercept -1/2, which is the reverse of what it was before, right?
Oh.
It all matches. That's like it all matches in the reverse.
Oh.
I just want to make sure you're seeing all the connections. I think that's all of them. Yes, you had a question, Nia?
The question is also be written as y is equal to 1 over x minus 2 plus 1.
The inverse, I'm sorry, the inverse of that. Y is equal to,
1 over x minus 2 and then outside of that plus 1.
y equals 1 over x minus 2 plus 1.
It's not like,
I don't know. How did you get that?
well, if you look at the equation and you divide numerator by x,
Ah. Okay.
1 is still being divided by x minus 2, but that x itself is been divided.
Nice. You could divide it through to put into the transformation form, I think is what you're talking about here. Right. So then you get this here. I think that this would be equal to 1 plus 3 over x minus 2. We could do that, but completely unnecessary considering what we've been doing. But it's a good way to verify. We still have our 1 as our horizontal asymptote set upward shift and it's been stretched. Thank you. I think I did that right. Yeah, that's good. Okay. Let's move on. Any questions? Any other questions? Thank you, Nia. Okay. Hey, look what's on this graph. A hole. Why do you think that there is a hole where it is?
Excluding not.
Take a moment to discuss with your neighbor. Where does that hole come from?
Oh, but.
Yeah.
Yes, but it's still part of the. We enact it out.
You got it.
Also, same way, like.
They cancel out, when like they cancel out, it's like plus. The X. Yeah, and that's why
But
it's
it's still
still,
in
that's
the-
what,
Yeah,
that's why.
that's why it's, oh, that's why.
Yeah, otherwise it would be.
Also.
Another.
So what's the connection here between the function that we see in the graph? Jonas.
It seems like that there's like, a hole where x equals 3, because that's the, one of the vertical asymptotes.
It would have been a vertical asymptote, right? Except it canceled out. Are we good with that? Right, this here canceled out, so what seemed before to have been a vertical asymptote is actually a hole. It's still an empty slot, but it's made a hole in our function. But how about the y value? Where did that? Can you find where? Because the coordinates of that hole are. It's not just like some random. The hole isn't down there. The hole is on the graph, like it's connecting. Where did that 2 come from? See if could you find it?
Oh.
Was that eight over?
Check with your neighbor.
Well,
I know. I know. I like it.
because they'll like it as well, and then- Oh, yeah. Because side of 8 divided by 4.
Four is.
Oh, what?
So then there's
It's like
3.
Yeah,
but you start.
Okay, so where does it come from? Max, yes.
Okay, so if we cancel out the x minus threes, we have x plus 5 over x plus 1.
Mhm.
And then if we plug in our 3, we get 8 over 4, which equals 2. So our y value needs to be at 2.
Are we good with that? We have to remember, nicely done. We have to remember that in our function, x cannot equal -1 or 3. Does that make sense? Those 2 numbers are not in the domain. But algebraically, we're able to work it out so we can plug in the 3. Just understand that this value, that 3 comma 2, is not actually on our function. It presents as a hole in the graph. Yes.
It's like a simple way, like to understand holes, is like it's the vertical asymptote that would have been there.
Oh, that's nice. The vertical asymptote that would have been
If it's
if it didn't cancel. Yeah. But it canceled, so it's a hole. Okay. So let's see what you can do. Oh, that just was weird. You still have on yours. Let me see if I can put this back. Come back. Okay. I want you to answer A. 2. So 1A, 2. I'll check a bunch of them. And you could just discuss with your neighbor and write it down as you're going. So you're doing these.
It's a negative. Wait, because 4 is also yeah. Oh, wait, okay, so.
I don't know why.
Just.
Are you just doing it?
I don't see why it was.
Everything's checked.
Oh my God.
All right, we got it.
Oh, wait, no, I do have it. What is it?
How many kids are eggs?
The degrees. Yeah, the degrees are.
I left
The coefficient. in front of it as well.
For number, right now, number four.
Okay, we're doing, oh, we're not doing B. We had one extra.
Hey, man, let me grab it back.
That's
That's
good.
And it's
Yeah.
95.
It's just the vertical. Yeah. So it's three, no, it's negative.
Is it one?
Okay.
So X
It's closer. Oh, it's gonna be a vertical.
Yeah. So the graph versus there.
It's increased. Right.
Why is it just? It's increasing.
X is negative one.
What do you equal?
One of the.
Oh, right.
Like they're approaching, they're, you have actually approaching plus or minus, right? You're approaching negative.
Make sure your neighbor's doing okay with all these.
That
For number four.
Oh, this is already. I think it's three.
it never touches these
The ratio would be 0 over. It gets
Oh, add negative one.
So what is happening, guys?
Oh, it decreased.
You'll like the graph.
Decrease in.
And then from the right, it's. Yeah.
It's a feature.
There's a hole.
Yeah.
Can you call that a hole? Good question.
Why do we?
Oh, sorry.
That's just closer to the graph like the.
Can I just, can you just say vertical asymptote? The graph approaches but never reaches.
I say.
And would it be approaching to both left and right?
It's on.
When X equals, as X get closer. So from both sides.
From the left, what is happening?
Oh, it would not, or not.
Is
No, it's like
wait.
right now. It's going.
I got it. So.
So five is decreasing and six is increasing.
This is what I.
Five and six is decreasing the.
I'm talking for like.
Oh, I guess, yeah.
Are you on?
Yeah.
Okay.
So these would both be two.
Yeah.
But it never actually.
Yeah.
Negative five. Yeah. I got it.
And then I wrote it. And then the ratio would be 0. And it also.
Where acceptable, where appropriate.
Yeah. Never.
Excellent.
And then.
So what do you mean by it would be zero?
So if we plugged in 3 here, this would equal 0. And the denominator would also be 0.
Again, use limit notation where appropriate.
And they're decreasing, right? The values are decreasing. From the right.
Okay, ready or not? Let's see what you got. Okay, folks. I'd like to hear from Leah for A. What'd you get?
Oh, G of X equals 1.
You got G of X equals 1?
X goes in and G of X equals 1.
How did you know that?
Of the 4, because of the horizontal axis.
Are we okay with that?
Yes.
Good. Oh, I am frozen. Thank you. And just for thank you very much, Leah. If you'd like, you could say this. What do you think that little plus sign means?
Coming from the right.
Yeah.
It's not coming from the right though. It's coming from above, isn't it? It's like kind of like landing on it, isn't it? That's completely optional. You could. It's optional.
Oh, how is that different from what we did on the number line? We used the negative from the left.
Well, on the number line, x is going to, that's left to right.
Yeah.
But the limit is equal to, that's a y value, so it's either from above or
Oh,
below.
okay.
Like if I were to say the limit as x is going to negative infinity of g of x, it's still one, but in this case, it's coming from below. Yeah, it's increasing to it, but it's coming from below. Do that right? It's always below it. Purely optional. Okay, graph of G has one intercept. What is it? Show me. Show me. Did I forget to show you how to? This is negative 1, 2, 3, 4, 5. So you don't have to do -5. Negative 5. It's a quick. So you could still write and -5. Okay.
It's just
Not
easier.
Okay. For 4, describe what's happening at the graph at x equals -1. Connor, what do you think? What's happening at -1?
X equals -1. Y is getting further away from y.
Looking for a feature here. What's happening at x equals -1 asymptote? What kind of asymptote? Vertical asymptote. And that happens because undefined denominator is x plus 1. So -1 will result in a 0 in the denominator. It's undefined. Vertical asymptote. Okay, and can you go on to number 5 for this? I feel like it's connected.
Oh, yeah, as x gets closer and closer to x equals -1 from the left, what is happening to the values of g? And they're getting increasingly negative.
Okay, how do I write that?
Lim,
Wait, yeah, for Connor.
lim, x, arrow.
Goes to?
-1,
-1.
X equals infinity, or negative infinity.
Okay. Are you complete there? X is going to -1. It's saying from the left, so I have to make sure to put a negative right there. Are we okay with that? Thank you. Pardon? Good question. Is the graph decreasing?
Yeah, say that.
Right there, is the graph decreasing there?
Yeah.
It's very definitely decreasing. But that has nothing to do with what we're talking about though. But talk about increasing, decreasing, it's always read from left to right. Okay, like a book or like a sentence, not even a whole book. Judy, can you tell us about 6? Oh, g of x, thank you. Good catch. Let me fix this one. Yeah. It's equal to. Are we good with that? Nice. So this is read limit of g of x as x approaches -1 from the right. Now, is that increasing or decreasing here? Is it increasing or decreasing? It can't be both. Remember, it's read from left to right if you're talking about increase to decrease. So it's very definitely decreasing. Even though our point of view is temporarily going from the right, but the function is decreasing there. Judy, thank you. Describe what's happening at x equals 3. Well, we already know it is a whole. It's a whole. As x is closer to 3 from the left, can you show me what's happening as x gets closer to 3 from the left? I should see a number. I should see a number. Yeah, it's a 2, isn't it? Right, as x gets closer to 3 from the left, that means like what's happening here? This y value, and then this y value, and then this y value. You can see that those y values are approaching 2. Yes?
How would we know like when to put it as a number or like when to use an infinity sign?
Well, if it's infinity, then use infinity. If it's a number, use a number.
5 and 6 is a number, but we still put in a negative.
Let's go through this one. Maybe the difference will make it clear. In this case, we're taking the limit of g of x as x is approaching.
2.
X is approaching
Oh, X is pretty.
3 from the left. So I'm just translating into this notation. Now that's just asking what's happening to these y values. Well, they're going to the limit again. Right here, when I plug in a 2, that's like 2 point something. When I plug in a 2.1, it's a little bit less. When I plug in 2.8, when I plug in 2.9, those values are very definitely going to 2 from above. But really all we care about is that it's equal to 2. That's all we care about. And if it's going to infinity, if there's a vertical asymptote, then we write infinity. There's no number. And if I wanted to, I could put what right here in that little circle? A little plus sign because it's approaching that 2 from above, isn't it? And we just know that graphically for now. You don't have to plug in numbers or anything. It's just we have the graph, so we're using it. From the right, the limit as x approaches 3 from the right of g of x is equal to 2. In this case, if we wanted to, we could say it's happening from below because it's going up to it or coming down after it. Yeah, so from below, and that symbol at the end is optional. So let's summarize what we've done. Finding holes happens when you have what kind of function? An irrational function. If x minus a cancels, then there is a hole at what's the x coordinate of the hole?
X equals that.
Yeah, a, comma, f of a.
Oh.
And this is the simplified form of the function. Because technically that a isn't even in the domain, so it's being a little bit naughty. It's a little bit naughty, but we were able to make it so that we could plug that in that number. So I'll give you a moment to work on these 2 examples.
So we would have to.
We also just say let's it's based on function equals to the denominator because of the x.
That'd be x in this.
Oh.
Nice try.
Oh, so it's 1 and 2 x.
It would be minus 3, right?
And 2x minus 1.
And then, yeah, for both,
Make sure everything okay with that first one.
I got.
when you plug it into.
Yeah.
Wait,
Not pretty old.
I got you.
Plug it back in.
Oh.
Wait, did I do it wrong?
I got
You're just
two
gonna plug it into like the equation.
Is it 2x minus 1 x minus 2? Where at the top?
Yeah, on the bottom and.
Yes.
Plug in.
Force. You're the man.
Two X minus four.
Yeah, when you plug it in, you go.
Nice. Three. And then just. If we, in the Y back, for Y back, so these two. This cancel.
You're
Oh my god,
plugging in
negative
two.
two, we're plugging in negative.
Then plug it.
Well, no, we're plugging in two.
You're plugging in two.
Yes.
Yeah.
And so for this, it would be two
Number
and minus one is three.
Yeah.
And divide that by five, or divide by four.
Yeah.
If you ever.
Take about 30 seconds.
Oh, yeah.
Yeah. Okay, guys. So this should
Is this gonna be on today's quiz?
Oh, so-
I'm sorry to let you down.
Yeah, the next question.
Yeah. And then let's do.
Oh, I got 40 and 31.
I got what's good.
And then.
Let's see. I think that's X minus one.
I should have negative. It should have been negative two.
Let me know when you're.
Oh, it's simplifies.
Okay, folks. I need some help. Like Post Malone. Are you ready? Ready or not? Let's see what you got. Emma, could you help me with this first one, please?
So if you do the bottom, it would be difference of.
When you say
squares.
do the, you mean when you,
Denominator, if you factor out the denominator.
oh, factor the denominator. Okay.
Yes, x plus two and x minus two, because it's difference of squares.
I like those terms. Good.
Then the numerator would be two x minus one, and then x minus two.
Okay. Do we agree? Okay.
And then we could cancel out the x minus two. And so if we put in f of two, when x equals two, you would get 3/4.
Do we agree? Which means that what?
The coordinates would be 2,3/4.
Okay. Thank you. Any questions? What's the domain of this function?
Oh, it can't be -2 and 2.
X cannot equal plus or minus 2. So how do you justify plugging in a 2? If X can't equal 2? It's a hole there, right? So we're not actually finding a point on the graph, we're finding a place where that hole is. Yes, Simon?
Domain like to whatever can't be zero before you cancel.
Yeah, exactly. Good. Nicely done, Emma. Thank you. And f of x, August, can you help me with this one, please?
Okay, yeah, I kind of got stuck on the difference of cubes.
Take as far as you can.
Okay, so you have the difference of squares, so you could put x plus one over, or in the numerator and x minus one. And then I know difference, I forgot the formula exactly, but I know there's an x minus one because the difference of the cubes, right? So
Okay,
I know
nice.
The whole will be at least, the x coordinate will be one.
Yeah. Okay,
I forgot.
nice.
So
Okay. Thank you for bringing this to our attention, because what happens if you forget this formula? Is there another way out of this? Wait, we know that x equals 1 is a 0 of this polynomial, isn't it? So how could you get the other factor? Synthetic division. Let's try that. You try using synthetic division to find the other factor here? Now, maybe you already know, but I want you to use synthetic division to do it.
What long division?
No, synthetic division.
Would it matter?
You should get the same thing. So in the little box, you're putting a 1. Outside the box, you're putting a 1, 0, -1. Is that right? 1, 1, 1, 1, 1, 2, 1. Did I do that right? Interesting. They can't be. Oh, this is 1. Where that 2 come from? 0. That makes most more sense. Okay, because I knew it was a factor, which means our other factor is there it is. So that's there for you if you forget how to use soap. Okay, so we have this. These cancel. We know that x coordinate is 1 and the y coordinate. Can you show me what it is? 2 hands is 2 over 3. Yes? Any questions? August, thank you. Thank you for, by the way, for not saying I can't do it. Thank you for taking us as far as you could. And then, yeah. But I hope that the thoughtful way out of that with the synthetic division makes sense. Perhaps your question is, can we start the quiz? Yeah. Okay, we can start in a minute. You need your own paper for this one. I'm gonna write it on the board. I know.
I like my notes.
For now you can.